Welcome to this video. Today we are going to discuss the method to derive the expression for stopping side distance. Firstly, let me share some of the points that I want to share regarding the stopping side distance, what it represents and how it is bifurcated to lag distance and braking distance. So basically, side distance is defined as it is the minimum side distance available on any highway at any spot having sufficient length to enable the driver to stop to avoid any collision, right? Second point is the stopping side distance is the sum of lag distance and braking distance. The spelling for this is wrong. Let me correct it. Braking distance, right? Lag distance is the distance the vehicle that travels during the reaction time and is given by Vt, where V is the velocity in meter per second and T is the time required for the driver to take reaction time for the driver. Next is braking distance. It is the distance traveled by the vehicle while braking operation is conducted, right? So for a level road, the SSD is calculated using the work done in stopping the vehicle and the kinetic energy of the vehicle, right? So let us assume if F is the maximum frictional force developed and braking distance is L and L is the braking distance, right? Then the work done against friction in stopping the vehicle would be given as FL, where FL is equal to small f into W into L, where W is the total weight of the vehicle. This would be total weight of the vehicle, total weight of the vehicle. L is the lag distance. F represents the frictional coefficient. Frictional coefficient, right? So it has to be equated with the kinetic energy at the design speed. So kinetic energy, as we know, is given by kinetic energy can be represented as 1 by 2 mv square. Here the V would be representing the design speed of the road, right? We'll equate these two to each other, so which will give us half mv square is equal to FWL, right? So L would come out to be W, then again can be written as, here W is equal to M upon G. So let me rewrite it for you. Half mv square is equal to F dot M upon G dot L. So mm will cancel out. L would be given as V square upon 2gf, right? See, so the SSD, as we know, would be given as SSD is equal to lag distance and the sum of braking distance, right? The lag distance would be V into T plus braking distance would be V square upon 2gf, right? Here F can have values from the following table. F is equal to coefficient of longitudinal friction. It can have values from the following table. as this column will represent the speed. This is F is equal to coefficient of friction, right? Then the speed in kilometer per hour. Speed here will be represented in kilometer per hour. As the speed is less than 30, the coefficient of friction would be 0.40. When the speed is 40 km per hour, the coefficient of friction would be 0.38. When speed is equal to 50, the coefficient of friction would be 0.37. When it would be 60, it would be 0.36. If the speed is greater than 80, the coefficient of friction is taken as 0.35. Right? In the next video, we'll cover how the side distance is calculated when the vehicle is moving at grade, yani when the vehicle is moving in horizontal or vertical gradient. Thank you. We'll meet you in the next video.